So today we will do Huygen's construction, but before we do that, let's define what is a wavelength. Now we know that this is how a wave propagates. So imagine these are the particles A, B, C, D of a medium. A wave propagates when a disturbance causes A to vibrate, and that vibration will pass from A to B, B to C, like that. Of course, the vibration can be left and right or up and down depending on what kind of wave we are considering. Now because B starts to vibrate a little later than A, B will not vibrate in step with A. Even C may not be in step with A, but it is possible for a wave to travel from A to D, and we call that a time period. Why a time period? Because imagine that A set out to vibrate and it completed one vibration, and by that time the wave had reached D, so that when A sets out for its next vibration, D also starts. Therefore, A and D will be vibrating in step with each other, and we say that the distance from A to D, which is the distance the wave travelled in the one time period, is called the wavelength. So A and D are said to be in phase with each other. So we define wavefront as being a line or a surface at which point every particle vibrates with the same phase. So that is a wavefront. More mathematically, we can say wavefront is a locus of all points at the same phase of vibration. Now, what are the shapes of the various wavefronts? Your syllabus mentions this, that you need to know the shape. So imagine a point source which is producing two-dimensional waves. So for that you can imagine a stone dropped on the lake, and we are considering the waves on the surface of the lake, which is a two-dimensional surface. So we know that the ripples move as concentric circles centered on the site of the disturbance. So these are, you can say, the shape of wavefronts produced by a point source in two dimension. So when a point source sends out a two-dimensional wave, the wavefront are circular in shape, like the way we have shown. And because the waves are traveling like this is a ray. So ray is a line that denotes the direction of travel of a wave. Now imagine as time passes, the wave move farther and farther away. Your circles will begin to have larger and larger radius, until when you are very far away, we can consider this to be a straight line. Why? Because it is a portion of a circle of very large radius. Therefore, when you are very, very far away from the source, a circular wavefront becomes a straight line. And if you have a point source in a three-dimensional medium, then the shape of the wavefront is going to be a sphere, and at very far away, at very great distance from the source of the disturbance, the wavefront is going to be plane. So these are, say, the two shapes of the wavefront. A point source in a two-dimensional, producing a two-dimensional wave, produces a circular wavefront, and that circular wavefront becomes a straight line at great distances from the source. When a point source produces a three-dimensional wave, like say shining a torchlight in the night where the spread is in all directions, then you have spherical wavefronts, and at very far away from the source of that disturbance, we can treat the wavefront as being plane. If you have a straight edge vibrator producing vibrations in a ripple tank, so imagine this is a ripple tank, and then I have got something like this going down and hitting the water, then the waves are going to be like this. It's going to move like this. So you will have waves as a straight line. So these are some examples. Now Huygen's construction enables us to find the future position of a wave if we know its present position. So he suggested two simple postulates. So imagine this is a circular wavefront. Huygen said every point on this circular wavefront can be considered to be the source of secondary wavelets. So say I want to find, so say this is wave P, I want to find its position after time delta t. Huygens said every point that we have that is there on the surface of this wave, and we take some arbitrary points like A, B, C, D. Of course, there will be infinite number of points. He said every point will send out a secondary wavelet, which is drawn as a semicircle, and the radius of this semicircle is going to be delta t into V, where delta t is the time interval after which we want to find the new position of the wave, and V is the velocity of your wave. So every point will set out a semicircle wavelet like this, and all of them are going to have the radius delta t into V, because time taken is the same and the speed of the wave in all directions is the same. So Huygens said the position of the new wavefront after time delta t will be the envelope of all these secondary wavelets. That is, it will be the tangent that passes through all the secondary wavelets. So after time delta t, the new position q of the wave is given by this one. If I want to find out the position after another time delta t prime, say, then again we do the same things. We consider points and then we draw semicircular wave fronts. This time they will have a radius of delta t prime into V, and then the envelope, or rather we will, and then the envelope of those new wave fronts like this one is going to be the source of, is going to be the new wavefront. So we will apply Huygens construction for reflection, for which we will prove angle of incidence is equal to angle of reflection, and we will also apply it to refraction, in which we will prove the Snell's law. So just to recap, a wavefront is a line or a surface at which every particle is in the same phase of vibration. Huygens construction allows us to find the future position of a wave if we know its current position, and for that he said every point on the wave is a source of secondary wavelets, and the new wavefront is the envelope that passes through the secondary wavelets.